சொல்லுங்க சார். கேச்சிடுவா. அட்டை பெட்டி இருக்கு. அது கேச்சிடுவா. இப்போ ஒர்க் அவுட் ஆகல அதை வச்சுக்கூடா. சரி பார்க்குறேன். ஒர்க் அவுட் ஆகல அதை வச்சுக்கூடா. சரி பார்க்குறேன் நான். கேச்சிடுறேன்.
TC SHAR 1 and 2.
Go ahead.
We observe both TC SHAR 1 and 2.
Copied. Go ahead.
We observe both telemetry carriers are on.
Copied.
All stations stand by for the time mark. T-minus 30 minutes and counting. Stand by for the time mark. T-minus 30 minutes and counting.
PSLV-C57, Aditya-L1 mission launch. Readiness for PSLV-C57, Aditya-L1 mission launch.
Met2 ROD and mission director. Benign weather conditions are prevailing for PSLV-C57. Met2 ROD and mission director. Benign weather conditions are prevailing for PSLV-C57.
ROD Roger.
Calling P1, switch on the pulsars.
नमस्कार, एक बार फिर स्वागत है आप सभी दर्शकों का। मैं विकास वर्णकार, एक बार फिर स्वागत है आप सभी दर्शकों का। मैं विकास वर्णकार, यहाँ श्रीहरिकोटा के मिशन नियंत्रण कक्ष से इंग्लिश कमेंटेटर मिस माधुरी प्रस्तुत करूंगा। सबसे पहले मेरे साथ हैं आप सभी दर्शकों को कमेंटेटर मिस माधुरी कामनाएं और बधाइयां। सबसे पहले मिशन की आप सभी दर्शकों को सफलता के साथ शुभकामनाएं और बधाइयां। चंद्रयान 3 चंद्रमा की सतह पर लैंडर की सफल लैंडिंग की 23 अगस्त 2023 के बाद चंद्रमा की सतह पर लैंडर की सकुशल लैंडिंग 3,80,000 किलोमीटर दूर चंद्रमा पर विचरण कर भारत ने अमिट पृथ्वी से 3,80,000 किलोमीटर दूर भारत चंद्रमा पर विचरण कर भारत की सकुशल उतरने वाला विश्व का पहला देश भारत चंद्रमा के दक्षिणी ध्रुव पर सकुशल उतरने वाला है। विश्व का पहला देश मार्गदर्शन और वैज्ञानिकों के सब संभव हो पाया है इसरो के ये तो सिर्फ मार्गदर्शन और वैज्ञानिकों के अथक प्रयास से, लेकिन ये तो सिर्फ शुरुआत है। इसरो तेजोमय सूर्य के अध्ययन के प्रयोजन से आदित्य-L1 नामक अंतरिक्ष यान तेजोमय सूर्य के अध्ययन के प्रयोजन से आदित्य-L1 नामक अंतरिक्ष यान को आज 2 भारतीय मानक समय के अनुसार श्रीहरिकोटा के 11:50 पर भारतीय मानक समय के अनुसार रॉकेट द्वारा सुबह 11:50 पर PSLV-C57 रॉकेट द्वारा विज्ञान के कुछ और रहस्यों से पर्दा उठाने आइए और वैज्ञानिक तकनीक का प्रदर्शन करने और विज्ञान के कुछ और रहस्यों से पर्दा उठाने इस मिशन में जिसका नाम है PSLV-C57 हमारे साथ मिशन। आज के इस मिशन में जिसका नाम है PSLV-C57 Aditya-L1 मिशन।
Namaste viewers, the Indian Space Research Organization is Namaste viewers rendezvous with the sun. The Indian Space Research to take you along on the live telecast of this momentous event today. I am take you along giving the commentary in English.
T4 Motor, you can switch on the radio.
Is my co-commentator giving the commentary in English.
T4 Motor, you can switch on the radio.
Is my co-commentator. We are about to script who will yet another chapter in the glorious space research history of India. We are about to script today yet another chapter in the glorious space research history of India. To carry Aditya-L1, the solar observatory of India, to be placed at a vantage point from where the solar observatory of India to be placed at a vantage point and while being in the visibility of Earth continuously observe the sun. And while being in the visibility of Earth became the first country in the world to safely land a spacecraft. 10 days ago, India became the first country in the world to safely land a spacecraft. I'm sure many of you were the eager and proud spectators of the Chandrayaan-3 landing. I'm sure many of you were the eager and proud spectators of the Chandrayaan-3 landing that was being telecast from ISTRAC, situated in Bangalore. We bring to you an integration film for the PSLV-C57 that took place in an integration Satish Dhawan Space Center, SHAR, Sriharikota. That took place in Satish Dhawan Space Center, SHAR, Sriharikota.
अभी आप अपने स्क्रीन पर देख रहे हैं यह है प्रथम कोर चरण अभी आप अपने 9 बूस्टर देख रहे हैं यह सेगमेंट प्रथम कोर चरण के 39 बूस्टर का नॉर्थ होती है और यह मिडिल सेगमेंट प्रथम चरण के ऊपर ये संयोजित किया जा रहा है और यह मिडिल सेगमेंट को इसके ऊपर संयोजित किए जाएंगे जा रहा है ऐसे मिडिल सेगमेंट इसके ऊपर संयोजित किए जाएंगे और संयोजित किया जाएगा और इस तरह तैयार होता है PSLV का संयोजित किया जाएगा और इस तरह तैयार होता है इसमें 139 टन का प्रणोदक होता है और यह इग्नाइटर है जो इसे प्रज्वलित करता है इसमें 139 टन का प्रणोदक होता है और यह इग्नाइटर है जो इसे प्रज्वलित करता है PSLV-C57 एक्सेल मिशन इस मिशन पे यह है PSLV 6 स्ट्रैप-ऑन बूस्टर्स एक्सेल मिशन में 12 टन के तो इसमें भरे जाते हैं 6 स्ट्रैप-ऑन बूस्टर्स ठोस नोदक पर आधारित 12 टन के नोदक भरे जाते हैं यह सब ठोस नोदक पर आधारित हैं यह SITVC टैंक को उठाकर इसके साथ संयोजित किया जा रहा है SITVC टैंक इंटरस्टेज आप देख रहे हैं इसमें संयोजित किया जा रहा हुए हैं पृथकन के लिए इंटरस्टेज आप देख रहे हैं इसमें रिट्रो मोटर्स लगे हुए हैं पृथकन के लिए और यह है द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है इसमें विकास इंजन लगा हुआ है द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है विकास इंजन लगा हुआ है
PSLV rocket prepared in the subsystem preparation facility of the PSLV rocket assembly prepared in the subsystem preparation facility and brought to the vehicle assembly building of the second launch pad to be integrated the third stage of the rocket and PS will be moduled. See this third stage PS3 and PS will be moduled respective showed and then handled together to be moved to the vehicle assembly building and then handled together to be moved to the vehicle assembly building.
ये नज़ारा आप देख रहे हैं व्हीकल असेंबली बिल्डिंग का जहां पर पूरे व्हीकल को देख रहे हैं असेंबल किया जाता है बिल्डिंग का जहां पर पूरे व्हीकल को असेंबल किया जाता है
These are the visuals from the clean room of the Aditya-L1 preparation facility prepared and ensconced into a protective Aditya-L1 spacecraft being prepared and where the environment is controlled and the temperature is controlled. The cleanliness is controlled. Where the environment is controlled and the temperature is controlled. At the vehicle assembly building again there is a clean room provision to safely at the vehicle assembly building again there is a clean room and the heat shield halves are closed. Integrated to now the vehicle is fully ready to be moved to the launch pad closed, which is about now the vehicle is fully ready to be moved to the launch pad, which is about 900. This is PSLV-C57 standing majestically. This is PSLV-C57 standing majestically.
PSLV-C57 का इंटीग्रेशन वीडियो अभी आपने देखा पूरी तरह तैयार C57 का इंटीग्रेशन वीडियो गतिविधियां जारी हैं पूरी तरह जारी हैं प्रमोशन से पहले की कुछ अंतिम गतिविधियां जारी हैं अंतिम जांच जारी हैं प्रमोशन से पहले की
We are bringing this telecast to you live from the Mission Control Center at Satish Dhawan Space Center, from the Mission Control Center at Satish Dhawan. The launch will take place today, SHAR, Sriharikota. The 2nd of September 2023. The launch will take place at 11:50 hours in 2nd of September 2023 from the second launch pad. At 11:50 hours in the PSLV-C57 in its XL version will carry Aditya-L1 spacecraft having a mass in its XL version will carry Aditya-L1 spacecraft having a mass of 1,435 by 19,500 kilometers orbit 235 by 19,500 kilometers orbit. The total mission duration will be of 3,799 seconds, or total mission duration will be 3,799 seconds. You can watch the live telecast on ISRO website, YouTube, Doordarshan. You can watch the live telecast on ISRO website, YouTube, Facebook and Twitter.
अब हम प्रमोशन से 22 मिनट की दूरी पर हैं। आदित्य-L1 से सूर्य का अध्ययन करने वाला पहला अंतरिक्ष आधारित भारतीय मिशन आदित्य-L1 इस मिशन का अध्ययन करने वाला पहला अंतरिक्ष आधारित भारतीय मिशन सूर्य पृथ्वी प्रणाली में मिशन से लैग्रेंज 1.L1 नामक के चारों ओर सूर्य प्रभामंडल कक्षा में लैग्रेंज 1 किया जाएगा के चारों ओर लैग्रेंज पॉइंट प्रभामंडल कक्षा में 15 लाख किलोमीटर दूर किया जाएगा। इस तरह L1 पर रखे गए उपग्रह से लगभग 15 लाख किलोमीटर दूर आच्छादन या ग्रहण इस तरह L1 पर रखे गए उपग्रह देखा जा सकता है तो बिना किसी आच्छादन या ग्रहण के लगातार यह अंतरिक्षयान विद्युत चुंबकीय और कण चुंबकीय क्षेत्र सूचकांकों का उपयोग करके अंतरिक्षयान विद्युत चुंबकीय और कण चुंबकीय क्षेत्र सूचकांकों का उपयोग करके जानते हैं। इनका निरीक्षण करने के लिए सबसे बाहरी परत जिसे हम कोरोना के नाम से जानते हैं, इनका निरीक्षण करने के लिए इनमें से 4 निर्धार सीधे सूर्य की गतिकी का अध्ययन करेंगे तथा अन्य 3 निर्धार से 4 निर्धार सीधे सूर्य की गतिकी का अध्ययन करेंगे तथा अन्य 3 निर्धार L1 बिंदु पर L1 उपग्रह के निर्धार कोरोनल तापन कोरोनल मास इजेक्शन इस तरह आदित्य और फ्लेयर गतिविधियों कोरोनल गतिविधियों और उनकी विशेषताओं और अंतरिक्ष और फ्लेयर गतिविधियों समझने के लिए गतिविधियों और उनकी विशेषताओं जानकारी और अंतरिक्ष मौसम की गतिशीलता को समझने के लिए अत्यधिक महत्वपूर्ण जानकारी प्रस्तुत है आदित्य-L1 कर्टेन रेजर। अब आपके सामने प्रस्तुत है आदित्य-L1 कर्टेन रेजर।
The PSLV-C57 is prepared to launch the 1,480 kg Aditya-L1 spacecraft into Earth-bound orbit, from which Aditya-L1 spacecraft into around the L1 point, from which it will be placed into a halo orbit is intended to study the Sun 4 months, and how it impacts the halosphere is intended to study the Sun and how it impacts the halosphere, which is the center of our solar system and has always fascinated humans, which is the center of our solar system and has always fascinated humans, is a ball of hot gases. The visible outer surface of the Sun is known as the photosphere. The visible outer surface of the Sun is known as the photosphere. After initially dropping through the chromosphere and then the Sun's temperature, after initially dropping through the chromosphere, reaching the Sun's temperature high values rises in the 3 million Kelvin, reaching extremely high values. The Aditya-L1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. Has 7 scientific payloads to conduct a comprehensive study of the Sun. VELC investigates the solar corona and the dynamics of coronal mass ejection. Investigates the solar corona and the dynamics of ultraviolet imaging telescopes. Suit payload scans the solar ultraviolet imaging light and detects fluctuations scans the solar disk in near ultraviolet light. The Aditya solar wind particle solar irradiance aspects and plasma analyzer solar wind particle experiment. PAPA payloads investigate the solar package for Aditya, as well as their energy distribution. The solar wind and energetic the solar low energy X-ray spectrometer distribution. Solexis and the high energy X-ray spectrometer, Helios, and the high energy X-ray flares from the sun over a wide energy Helios analyze X-ray flares from the sun over a wide energy to measure the interplanetary magnetic field. The magnetometer payload is designed to measure the interplanetary magnetic field at the L1 point. Is equipped to take in situ measurements of charged particles and fields. Is equipped to take in situ measurements of charged particles and fields across several energy bands, and is dedicated to studying the sun across several energy bands. 1.5 the Lagrange point L1 from the Earth is located around the Sun and 1.5 million kilometers. These observations are between the Sun and from a vantage point that provides a continuous observations are best made from a vantage point that provides a coordination view with ISRO centers and national laboratories are designed in close coordination with ISRO centers and national laboratories countries like as with this mission. ISRO will once again demonstrate its position in space exploration. Will once again demonstrate its position in space exploration.
We are 17 minutes 23 seconds from the launch time. We are 17 minutes for PSLV-C57 from the launch time. Aditya-L1 mission. The countdown for PSLV-C57 started yesterday. Aditya-L1 mission has been 24 hours. During the countdown, critical activities have been carried out on the launch vehicle and the spacecraft. During the countdown, critical activities have been carried out on the launch vehicle and the spacecraft. Bottles storing the gas propellant have been serviced into the launch vehicle operations have been charged. Bottles storing the gas pressure command and control operations onboard batteries to have been charged pressure levels. The onboard batteries now in a little while will go to the automatic launch sequence initiation. Now in a little while will go to the automatic launch sequence initiation for which the launch and mission preparations are underway. In the launch and mission control centers.
Ready for PSLV-C57 Aditya-L1 mission. Mission Director Roger for PSLV-C57 Aditya-L1 mission.
Mission Director Roger confirms readiness of all its track stations and network for supporting.
अभी आपने सुना.
Readiness of all Aditya-L1 stations and
Mission Director Roger.
अभी आपने सुना. उपग्रह निदेशक,
TCTC data log for 10 minutes, short 1 short to station.
उपग्रह निदेशक,
TCTC data log for 10 minutes, short 1 short to station.
तथा यान निदेशक ने अपने तंत्रों की सूचना मिशन निदेशक को दे दी है.
T-16 minutes and
सभी आंकड़े संतोषजनक होने पर
T-16 minutes and
सभी आंकड़े संतोषजनक होने पर
Already given clearance for proceeding with the countdown and authorization board PSLV-C57 already given clearance Aditya-L1 with the countdown and launch all operations in the countdown sequence till automatic launch sequence have been completed. All operations in the countdown sequence till automatic clearance sequence obtained from launch vehicle satisfactorily range based on the clearance obtained from launch vehicle favorable weather condition range. Mission Director hereby authorizes to initiate favorable weather condition sequence. Mission Director hereby authorizes to initiate Aditya-L1 mission for the launch of 50 hours IST today. Aditya-L1 mission 2nd September 2023 hours IST today. That is 2nd September 2023.
For the launch of PSLV-C57, Mission Director has given authorization for the launch of PSLV-C57.
अभी आपने देखा इस मिशन के मिशन डायरेक्टर श्री SR बीजू ने देखा इस मिशन के मिशन डायरेक्टर श्री SR बीजू ने इस मिशन का
Automatic launch sequence for the launch of PSLV-C57 Aditya-L1 mission. Automatic launch sequence for the launch of PSLV.
Automatic launch
Aditya-L1
launch sequence initiated for PSLV-C57 Automatic L1 mission. Launch sequence initiated for PSLV-C57 Aditya-L1 mission.
The initiation has been announced. The automatic launch hereafter a very initiation has been announced. Performance validation for the launch vehicle systems will be carried out. And very close to the launch validation for the launch vehicle systems will be carried out on to the onboard close to the launch time. Control will be passed on to the onboard computers.
जी हाँ, ऑटोमेटिक लॉन्च सीक्वेंस चालू हो चुका है. ALS शुरू होने के पश्चात सीक्वेंस चालू हो चुका है. रॉकेट स्वचालित होकर सर्वप्रथम ALS शुरू होने के पश्चात 0.3 सेकंड्स पर रॉकेट स्वचालित होकर शुरू करेगा और T0 पर 0.3 सेकंड्स पर RCT का प्रज्वलन शुरू करेगा और T0 पर कोर इस दौरान स्वचालित तरीके से सभी जांच जारी रखे हुए हैं. लेकिन इस दौरान स्वचालित तरीके से सभी जांच जारी रखे हुए हैं.
On your TV screens, Honorable Minister of State for Science and Technology and Prime Minister's Office. On your TV screens, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh. This mission is the 91st launch mission of ISRO and 59th. This mission is the 91st launch mission of ISRO. As mentioned earlier, PSLV's XL version was PSLV. 6 strap-on motors alongside the core L. PSLV's XL version motor 6 strap-on used for the alongside the core L. This is the 25th time motor PSLV XL is being used for the present mission. This is the 25th time so far in the year 2023 ISRO has launched SSLV's maiden successful mission. So far in the year 2023 commercial missions has launched SSLV's maiden successful mission carrying the first among the commercial generation of navigation satellites, one mission of GSLV, one commercial mission the first among the second generation of navigation another mission of LVM3, one commercial mission of carrying the prestigious Chandrayaan-3 spacecraft of LVM3 again carrying the prestigious Chandrayaan-3 spacecraft.
PS4 control system actuation in progress.
आदित्य-L1 जो कि एक अंतरिक्ष यान है इस मिशन का, इसको आदित्य-L1 235 बाई 19,500 किलोमीटर की निम्न भूकक्षा में 19.35 बाई 19,500 किलोमीटर की झुकाव के साथ अंतरिक्षेपित किया जाएगा। इस कक्षा में निर्धारित आर्ग्यूमेंट ऑफ झुकाव के साथ अंतरिक्षेपित किया जाएगा। इस कक्षा में निर्धारित आर्ग्यूमेंट ऑफ पेरिजी PSLV के चतुर्थ चरण को 2 बार प्रज्वलित कर प्राप्त करने के लिए PSLV के चतुर्थ चरण को 2 बार प्रज्वलित कर और पेरिजी के बीच के कोण है जिसे कक्षीय तल के साथ और पेरिजी के बीच के कोण है जिसे कक्षीय तल के साथ मापा जाता है। आदित्य-L1 के इस दीर्घाकार कक्षा में अंतक्षेपण के पश्चात आदित्य-L1 के इस दीर्घाकार कक्षा में अंतरिक्ष यान के पश्चात अंतरिक्ष यान में लगे लिक्विड एपोजी मोटर्स को फायर कर अंतरिक्ष यान किया जाएगा और अंतरिक्ष यान में लगे लिक्विड एपोजी मोटर्स को फायर कर कक्षांतरण किया जाएगा और इस तरह पांचवी बार में बाहर मोटर को फायर कर यान को पृथ्वी की प्रभावी क्षेत्र से पृथ्वी की कक्षा से छोड़कर सूर्य की कक्षा में प्रवेश करेगा और ऐसा करते हुए पृथ्वी की कक्षा से छोड़कर सूर्य की कक्षा में प्रवेश करेगा लगेगा और ऐसा करते हुए 125 दिनों बाद यह L1 पॉइंट के पास समय लगेगा और उसकी परिक्रमा करना शुरू कर देगा। 125 दिनों बाद यह L1 पॉइंट के पास पहुंचकर और यही वह L1 पॉइंट है जहां पर से यह अपने वैज्ञानिक उद्देश्यों का भी प्रतिपादन करेगा और यही वह L1 पॉइंट है जहां पर से यह अपने वैज्ञानिक उद्देश्यों का भी प्रतिपादन करेगा। अब हम उड़ान से 11 मिनट की दूरी पर
कंट्रोल सिस्टम एक्चुएशन इन प्रोग्रेस।
Let me in the meantime tell the viewers about the flight events that the launch of PSLV-C57 tell the viewers about the flight events that the launch of PSLV-C57 this mission is among the longest flights of PSLV take. It is going to last for this mission is among the longest flights of PSLV. It is going to last the liftoff coincides with the ignition of S139 solid rocket motor. The liftoff coincides with the ignition of the 4 ground-lit S139 solid rocket motor. While the rocket is at 2.7 kilometers altitude strap-ons. The 2 air-lit strap-ons also commence their operation. 2.7 kilometers altitude. The action time of strap-on motors strap-ons also commence their operation. The ground-lit and air-lit strap-ons as operated motors as ongoing launch vehicle. And the ground-lit 70 and air-lit strap-ons as operated from the ongoing launch vehicle. At 70 and 92 seconds S139 motor continues to thrust till 110 seconds. Core S139 motor continues to thrust. Since the second stage of PSLV operates on pressure-fed liquid engine, the optimal performance of the stage of PSLV operates on pressure-fed liquid engine, the optimal performance of the engine is ensured. Thrust cutoff or separation of the lower stage is countered by additional means. Thrust cutoff or separation of the lower stage. Therefore, the Alish motors provided for this purpose ignite 3 seconds before the first stage. Therefore, the Alish motors provided for this purpose ignite 3 seconds before the first stage separation. The second stage PS2 commences its operation 200 milliseconds after the second stage. PS2 commences by this time the rocket would have milliseconds after 55 kilometers altitude. By this time, the rocket would have initiated 55 kilometers which compares the present stage of rocket to the intended injection point to compute an optimal compares the present stage of rocket while the rocket injection point to compute an optimal altitude. This happens while the rocket is at 59.7 kilometers altitude. Is separated. As the launch vehicle attains 130 kilometers altitude and the dense atmosphere is no longer present around. Kilometers altitude and the dense atmosphere is no longer present around. These events are taking place in the operational regime of the second stage which lasts for 153 These events are taking place in the operational regime of the second stage which lasts for 262.4 seconds into the flight. PS2 is at an altitude of 232.4 seconds while the relative velocity is at an altitude of 130 kilometers. The third relative velocity ignites about 9 later and burns 418 seconds. The third stage PS3 during which time about it adds 12 kilometers to the altitude and enhances relative velocity during which time it adds 12 kilometers to the altitude and enhances relative velocity 7.3 kilometers per second. From 4.9 kilometers per second to 7.3 kilometers per second. Burnout. during which there is no thrust being developed. But the rocket continues to be steered, during which there is no thrust being developed seconds into the flight, the rocket continues to be steered. And the last 581 seconds into the flight, the PS3 separates with the Aditya-L1 spacecraft coasts for a long time thereafter. With the Aditya-L1 spacecraft coasts for a long time thereafter. 1396 seconds into flight, the tracking station sets SHAR Port Blair, 1396 seconds into flight, the real-time station sets SHAR Port Blair, Brunei and but thereafter there is no visibility period of around data of the flight. 1600 seconds or 27 thereafter there is no visibility period of around twice. 1600 seconds or for a duration of 30 seconds. The fourth time burns duration of first time for a duration of 30 seconds. And the first burn takes place in no visibility zone. 72 seconds. The second burn is tracked by a ship-owned terminal in no visibility zone in Pacific Ocean. Is tracked by about 200 seconds after the completion of second burn of PS4. The injection about 200 seconds for the separation of Aditya-L1 are expected to be achieved. The injection conditions and altitude of for the separation of Aditya-L1 are expected to be achieved. And a relative velocity of 8.9 kilometers per second, which and a relative velocity of 2.95 per second, 19,500 translates into an orbit of 235 the injection event of Aditya-L1 will be confirmed by tracking station at Kourou. The injection event of Aditya-L1 will be confirmed by low Earth orbit. Aditya-L1 will undergo a series of earthbound orbit raising low Earth orbit, and eventually Aditya-L1 will undergo a series of earthbound orbit raising to reach, and eventually it will exit Lagrange's point L1 sphere of influence to reach in a journey spanning over 4 months. Point L1 where it will be placed in a halo orbit spanning over 4 months. This is how India's first in a halo observatory class L1 space-based. This is how solar mission will take shape. Observatory class space-based solar mission will take shape.
अब हम उड़ान से 6 मिनट की दूरी पर हैं। ALS जारी है। अब हम सभी जांच सुचारू रूप से जारी हैं। ALS जारी है। सभी जांच सुचारू रूप से जारी हैं। इस दौरान यहाँ उपस्थित आप देखिए यहाँ इस दौरान व्यूअर्स गैलरी पे उपस्थित लॉन्च व्यू गैलरी पे यहाँ उपस्थित एक्सटर्नल पावर सप्लाई सर्वे व्यूअर्स गैलरी पे लॉन्च व्यू गैलरी पे रोमांच देखते ही बनता है। इनका रोमांच देखते ही बनता है। यहाँ लगभग 37 डिग्री का टेम्परेचर है। मौसम यहाँ 0.8 मीटर पर सेकंड 37 डिग्री का टेम्परेचर है। वायु गति के बावजूद यहाँ उपस्थित हुए हैं इस रोमांच को देखने के लिए। इन सब के बावजूद यहाँ उपस्थित हुए हैं इस रोमांच को देखने के लिए। एयर ट्रैफिक कंट्रोलर और मौसम विभाग की अनुमति भी प्राप्त की जा चुकी है। विभिन्न ऊंचाई पर वायु गति माप ली गई है और इसे ऑन बोर्ड की जा चुकी है। लोड कर दिया गया है। ऊंचाई पर वायु गति माप ली गई है और इसे ऑन बोर्ड कंप्यूटर पर
Dhawan Space Center has its own meteorology department which keeps a very close Satish Dhawan Space Center on the weather at the launch base which keeps a very close watch whether today on the weather at the dry and hot. The skies will remain clear. Whether today is going to be dry and hot. Ground winds, the skies will remain upper winds also are benign for the flight of PSLV. Ground winds will be benign and upper winds also are benign for the flight of PSLV-C57 Aditya-L1 mission. We are 4 minutes 23 seconds to the launch. We are 4 minutes 23 seconds to the launch.
सभी वैज्ञानिक अपने कंसोल पर आंकड़े देखते हुए सभी वैज्ञानिक अपने कंसोल पर निष्पादन कर रहे हैं देखते हुए अब हम सभी 4 मिनट की दूरी पर सामान्य निष्पादन कर रहे हैं।
T-4 minutes and counting.
4 मिनट की दूरी पर सामान्यतः PSLV के मिशन लगभग 2000 सेकंड में प्राप्त कर लिए जाते हैं। सामान्यतः PSLV के मिशन कुछ लगभग 2000 मिशन में सेकंड में प्राप्त कर लिए जाते हैं। PS4 मिशन कुछ अलग है। 2 बार में प्रज्वलित कर PSLV के चतुर्थ चरण यानी PS प्राप्त की जाएगी। 2 बार में प्रज्वलित कर PS4 को प्रतिष्ठ फेज के बाद प्रज्वलित किया जाएगा। PS4 30 सेकंड प्रज्वलित रहकर रोस्टिंग फेज के बाद प्रज्वलित किया जाएगा। 1600 सेकंड की कोसेकंड प्रज्वलित रहेगी या बंद हो जाएगा। फिर करीब 1600 सेकंड की PS4 को प्रज्वलित कर 472 सेकंड तक फिर से उत्पन्न किया जाएगा। PS4 को प्रज्वलित कर शांत हो जाएगा। 472 सेकंड की कक्षा की स्थिति प्राप्त होते ही और फिर शांत हो जाएगा। कक्षा में L1 की कक्षा की स्थिति प्राप्त होते ही उसे निर्दिष्ट कक्षा में मिशन में लगभग 3800 सेकंड का समय लगेगा। इस तरह पूरे मिशन में लगभग 3800 सेकंड का समय लगेगा।
T-3 minutes and counting. T-3 minutes and counting.
यह PSLV-C57 का प्रमोशन यान ट्रैकिंग के संदर्भ में भी काफी जटिल है। PSLV-C57 करने के लिए SHAR पोर्ट ब्लेयर ट्रैकिंग के संदर्भ में भी काफी जटिल है। हमें वास्तविक ट्रैक करने के लिए SHAR जानकारी उपलब्ध कराते रहेंगे और बैक स्थित ग्राउंड स्टेशन हमें वास्तविक समय पे यान चरण के प्रज्वलन उपलब्ध कराते रहेंगे। समय यान हमारे ग्राउंड स्टेशन की दृष्टि से दूर जा चुका होगा। चरण के प्रज्वलन शिपबोर्न ट्रैकिंग समय यान हमारे ग्राउंड स्टेशन की दृष्टि से दूर जा चुका होगा। महासागर में शिपबोर्न ट्रैकिंग या शिपबोर्न टर्मिनल को दक्षिणी पैसिफिक महासागर में स्थित जानकारी उपलब्ध कराएगा। इसके बाद PS4 शट ऑफ और Aditya-L1 के जानकारी उपलब्ध कराएगा। इसके बाद PS4 शट ऑफ और Aditya-L1 के अंतःक्षेपण की पुष्टि कुरु फ्रेंच गयाना स्थित ग्राउंड स्टेशन से की जाएगी।
T-2 minutes and counting. T-2 minutes and counting.
अब हम उड़ान से 1 मिनट 50 सेकंड की दूरी पर, यह PSLV की 59वीं उड़ान की दूरी पर और इस PSLV यह PSLV की 59वीं उड़ान है और इसरो के वर्क हॉर्स कहे जाने वाले इस रॉकेट में यह 25वीं उड़ान मिशन को सफलतापूर्वक संपन्न किया है। जाने वाले चंद्रयान-1 कई ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है। यह प्रमोशन चंद्रयान-1 2023 का 7वां मिशन होगा, उल्लेखनीय है। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन GSLV Mark 2 का एक और यह PSLV के वर्तमान वर्ष में तीसरा मिशन है। यह PSLV का वर्तमान वर्ष में तीसरा मिशन है।
All stations stand by for the time mark. T-1 minute and count. All stations stand by for the time mark. T-1 minute and 55 seconds.
All subs are armed.
Minus 55 seconds.
All subs are armed. All sequencers armed.
Minus 50 seconds.
तो हमारे साथ बने रहिए।
All sequencers armed.
40 सेकंड पर हमारे साथ बने रहिए। प्रमोशन किया जाएगा। 40 सेकंड पर
minus 35 seconds.
प्रमोशन किया जाएगा।
Minus 35 seconds. 30 seconds.
Real time programs activated.
Minus 30 minus seconds. 25 seconds.
PS2 VSPP open.
Minus 25 seconds. 20 seconds.
PS2 VSPP open. PS on ignition RMS arm.
Minus 20 seconds.
PS on ignition RMS arm.
Minus 15 seconds. 10, 9, 8, 7, 6, 10, 5, 9, 4, 8, 3, 7, 2, 6, 1, 5, 0, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Plus 5 seconds.
Magnificent liftoff of PSLV-C57 with Aditya-L1 on board. Magnificent liftoff of PSLV-C57 with Aditya-L1 on board.
उत्थापन और इसके साथ PSLV-C57 का सफल उत्थापन निकल चुका है। सूर्य के तेज से विज्ञान को प्रकाश करने सौर अंतरिक्ष यान निकल चुका है। सूर्य के तेज से विज्ञान को प्रकाश करने अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The rocket flying forth, following nominal trajectory and developing nominal thrust. Rocket launches more than just a sight to behold. The roaring sound and the vibrations that we can feel here. Adding to this, the roaring sound and the vibrations that we can feel. Groundlit and adding to this, the thrill are just operating together with the groundlit and stage S139. Operating together with the first stage S139.
Groundlit strap-on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है जैसा कि निर्धारित है और प्रथम चरण का निष्पादन सामान्य स्ट्रैप ऑन को सेपरेट कर दिया गया है। अगला एयर लेड स्ट्रैप ऑन चरण का निष्पादन सामान्य कर दिया जाएगा। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा। जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप-ऑन को सफलतापूर्वक पृथक कर दिया गया है। जी हाँ, इसकी भी पुष्टि हो गई है।
100 seconds past the launch time. The ground-lit and air-lit strap-ons have been separated. 100 seconds past the launch time. The ground-lit and air-lit strap-ons have been separated. S139 motor
110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है। 110 सेकंड के प्रज्वलन काल के पश्चात चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है। द्वितीय चरण वर्तमान में प्रणोद तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
Launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation. First stage has been separated. Has been initiated. Second stage has begun its operation according to the announcement by Range Operations Director. PS2 is developing according to the announcement by Range Operations Director. PS2 is developing nominal
41 टन के तरल नोदक पर आधारित चरण है। PS2 इसमें विकास इंजन द्वारा तरल 800 किलो न्यूटन का प्रणोद उत्पन्न होता है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150
SHAR
सेकंड
and
का
Port
होगा।
Blair tracking stations presently acquiring signals. SHAR and Port Blair flight path closely matching acquiring signals.
+3 minutes.
Flight path closely matching the prediction.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है। वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है। ऊंचाई 106 किलोमीटर तथा सापेक्ष गति यान की ऊंचाई किलोमीटर 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second. The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second. The payload fairing covering the Aditya-L1 spacecraft has been separated. Payload fairing, the current altitude of the Aditya-L1 spacecraft has been separated. The current altitude of the launch vehicle is velocity exceeding kilometers, 3.8 kilometers per second. Velocity exceeding 3.8 kilometers per second.
घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है। वातावरण से बाहर जा चुका है, इसे पृथक कर दिया जाता है। कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है। द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह द्वितीय चरण सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated, third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है। उसके प्रज्वलन काल समाप्त होने पर चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है, जो कि प्रज्वलन नोदक पर आधारित चरण है। इसे और प्रज्वलन शुरू हो चुका है, जो कि ठोस नोदक पर आधारित चरण है। इसे इसका प्रज्वलन शुरू हो चुका है।
5 minutes past the launch time. Presently, we are the third stage of PSLV is the launch time, developing nominal thrust. The third stage of PSLV is operational, developing nominal thrust.
5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है। तृतीय चरण प्रज्वलन काल 7.6 टन के ठोस नोदक का प्रयोग होता है और इस दौरान प्रज्वलन काल 240 किलो न्यूटन का प्रणोद उत्पन्न करेगा होगा। इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है। जैसा कि हम जानते हैं PSLV ही प्रदर्शन करता हुआ एक और मिशन रॉकेट रहा है C57 का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV-C57 का।
For the present mission, after PS3 completes its burn duration, for the present mission, coast phase after PS3 completes its burn duration, in which the rocket will continue to be steered while there is no development of thrust. In which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है। में PS3 का कोस्टिंग फेज के बाद प्रज्वलन काल समाप्त हो चुका है और होस्टिंग फेज इसके बाद जारी रहेगा।
approximately 200 seconds. Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the PS4 unique to this will mission start twice. The PS4 it pre-designated will start and twice. It pre-designated time. The multiple start capability of PS4 will be utilized very aptly to achieve the argument of PS4 will be utilized very aptly to achieve the argument of very crucial for this mission of 346 commencement and duration of PS4 burns enable achieving this orbital parameter. The commencement and duration of PS4 argument burns of enable achieving this orbital parameter. By the perigee point from the ascending argument node of perigee is the angle that is made by the perigee point from the ascending node is helpful in mission planning to achieve halo orbit around L1 with minimal helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का जो कि ग्राउंड स्टेशन द्वारा गहनता से अध्ययन किए जा रहे हैं आंकड़ों का जो कि ग्राउंड स्टेशन द्वारा PS3 प्रसारित किए जा रहे हैं। होस्टिंग फेज जारी है। वर्तमान में यान की ऊंचाई PS4 कंबाइंड 70 किलोमीटर जारी है तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है। 70 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal. Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya-L1. Describing the sun. Speaking
Indian
a few
Vedas
words
have
about
said,
the Aditya-L1. Describing the sun. Indian Vedas have said, Deepako Brahmanda Bhandasya. Deepako Brahmanda Bhandasya. This mighty jewel, the light of eastern sky, who generates, operates, and this mighty jewel, the light of eastern sky, the energy of sun, after having filtered by the atmosphere, is available for the sustenance of Earth. After having filtered by the phenomena in sun, is available for the sustenance of cause for concern to the spacecraft and human and the solar flares. Are a cause for concern. The vantage point for such observations is a place in between the sun and Earth. The vantage point for such observations is a place in between the sun and Earth. Now we have a successful separation event of we have a third stage of PSLV separation event of the third stage of PSLV.
Plus 10 minutes.
Approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक पृथक कर दिया गया है और अब जी हाँ, तृतीय चरण को सफलतापूर्वक पृथक कर दिया गया है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से इस दौरान कोई भी आगे बढ़ता हुआ उत्पन्न नहीं हो रहा है। यान अनुकरण करता हुआ जा रहा है, आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. We are the 627 or so we will be getting the launch tracking for data from the BIAX ground station. Also we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लगभग लैंग्रेंज पॉइंट से जुड़े कुछ रोचक तथ्य भी हैं, जैसे हम आपको कुछ जानकारी देते हैं का नाम लैंग्रेंज पॉइंट से जुड़े कुछ रोचक तथ्य भी हैं, जैसे कि लैंग्रेंज के समान पॉइंट का नाम एक इटालियन फ्रेंच 1972 में इसे लैंग्रेंज के समान में रखा गया था। 3 बॉडी प्रॉब्लम 1972 में इसे अपनी तकनीकी प्रपत्र, लेकिन इससे पहले भी 3 बॉडी प्रॉब्लम में वर्णित किया है। L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लेनार्ड आयलर को जाता है। L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ नासा ने पहले ही सोलर एंड हेलियोस्फेरिक पॉइंट पर ऑब्जर्वेटरी ने पहले ही पहुंचा चुका है एंड और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप पृथ्वी से L2 लैग्रेंज सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है। पृथ्वी से सूर्य की दिशा एस्ट्रोनॉमिकल दूरी लगभग 15 लाख किलोमीटर है। एस्ट्रोनॉमिकल यूनिट कह सकते हैं यह एस्ट्रोनॉमिकल यूनिट सूरज की दूरी का केवल 1% है। एस्ट्रोनॉमिकल यूनिट कह सकते हैं यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun is a place in between the sun and earth where direct visibility exists to the sun. These observations while continuous communication link exists with the earth. Disturbances in near Earth generate a forewarning about pose danger to the communication system and spacecraft, which could pose danger thermal and magnetic phenomena on the sun are of extreme nature, which cannot be thermal and magnetic phenomena on the sun. The best way is to observe the sun, which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. The distance between the Earth and Sun is approximately 150 known as core. The temperature can reach as high as the central region of the Sun known as core. The temperature can reach power source as high as nuclear fusion of hydrogen atoms. Power source for the Sun is nuclear fusion. The visible surface of Sun hydrogen relatively cool that takes place and has a temperature of about the visible surface of Sun is relatively cool and has a temperature of about the Aditya-L1 spacecraft is planned to be placed in a halo orbit around the Aditya-L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point, which is about 1.5 million kilometers from Earth system, which is about 1.5 million kilometers from Earth. A halo orbit is a periodic three-dimensional orbit near the Lagrangian point. A halo orbit is a periodic three-dimensional orbit near the Lagrangian three-body problem of orbital mechanism. In the three-body problem, in this orbit stays in place by the gravity of Earth and Sun. The object requires little energy for stays in place by the gravity of Earth. Several probes have been placed in space to observe the station keeping by various space agencies. Several probes have been placed in space to observe the sun. Point L1 is a great location for solar explorers such as Aditya-L1. Lagrange's point L1 is for an unobstructed view of the sun that is never Aditya-L1. As it allows for an unobstructed view of the sun that is never L1 will join spacecraft such as ESA NASA's solar heliospheric observatory join spacecraft such as ESA NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज पहुंचती है तो वह वही बनी जगह है अंतरिक्ष में जहां अगर कोई बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है। बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ अभिकेंद्रीय बल है। ऐसे जो 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच, ऐसे 5 लैग्रेंजियन पॉइंट्स को भेजकर कम से कम सूर्य के बीच या इन पॉइंट्स में उस स्थान पर अंतरिक्ष प्रयोगों को कम अध्ययन के लिए बनाए रखा जा सकता है। उस स्थान पर अंतरिक्ष प्रयोगों को भी ऐसे ही लैग्रेंज रखा जा सकता है, स्थापित किया जा रहा है। Aditya-L1 उपग्रह को भी ऐसे ही यहाँ तक पहुँचने में 125 दिन स्थापित किया जा रहा है। अंतरिक्ष यान को यहाँ तक पहुँचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ Aditya-L1 के बारे में बात कर रहे हैं, कुछ तो फायदे होते हैं जैसे हम यहाँ के पास जाएगा के बारे में बात कर रहे हैं। ऐसा पॉइंट है जहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना जाएगा और ग्रहण या रुकावट के निरंतर देखा जा सकेगा, जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा, विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की दूसरा फायदा यह कि विभिन्न मापन या विश्लेषण वायु न होने की वजह से तरह की इसे रुकावट या कमी नहीं देखा जा सकेगा। वायु न होने की वजह से पर इसे वेधशाला को रखने का मुख्य कारण यह जा सकेगा कि यहाँ उपग्रह लगभग पॉइंट रहेगा। इस वेधशाला को रखने का मुख्य कारण यह भी है अधिक यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृद्धि नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। वर्तमान में यान की ऊंचाई 280 किलोमीटर जारी है तथा सापेक्ष गति 7 यान की ऊंचाई 280 किलोमीटर है तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है कर पुनः प्रज्वलित किया जाएगा। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere. The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere. These payloads use electromagnetic particles and magnetic field detectors. These payloads use first among the foam remote sensing and magnetic field detectors. Visible emission first among the foam remote sensing payloads is a prime payload emission designed as a reflective coronagraph with a multi-prime payload designed as a payload is developed jointly by the Multi-Slit Spectrophysics Laboratory of Electro-Optical jointly by Indian Institute of Satellite Center, Laboratory of Electro-Optical Systems and Space Application Center. ISRO Inertial Second Payload Unit Solar Low Energy X-ray Spectrometer or the second payload is Solar Low Energy X-ray designed to measure the solar soft X-ray flux to study designed to measure the solar payload is developed by URL solar flares. This payload is developed by URL Solar Earth Ultraviolet Imaging Telescope. Third payload is the Solar Earth, which is a UV telescope imaging to image the solar disk suite in the near, which is a UV telescope to image the solar disk. The payload is developed by Ultraviolet Center for Astronomy and Astrophysics. The payload is developed by Inter-University Center for URSC Astronomy and Astrophysics, Pune. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer. The fourth payload is High Energy developed by URSC Orbiting X-ray Spectrometer. Hard X-ray Spectrometer developed by URSC solar flares in high energy. Hard X-ray Spectrometer designed to study solar flares in high energy. The one which is meant for the fifth payload observations. Is the one which is meant for Aditya Solar Wind Particle Experiment. There are this is otherwise called as wind particle experiment, which comprises of spectrometers, otherwise called as energy particles, and which comprises of spectrometers. This payload is developed by Physical Research Laboratory and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya. In short, payload is Plasma Analyzer Package for Aditya to, in short, PAPA. It understands the solar winds and its composition and perform mass analysis. Understands the solar winds and its composition. This payload is developed by Vikram Sarabhai Space Center of solar winds. The seventh payload is developed by Vikram Sarabhai Space Center, which will measure the low intensity interplanetary or MAG developed by LEOs, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति के बारे में जानते हुए नितभार लगे हुए हैं। इसमें सुदूर संवेदन नितभार में और यथास्थिति प्रेक्षण करने के लिए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए वर्णक्रम मापन के लिए LC सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि सक्रिय है और ब्रॉडबैंड फ्रीक्वेंसी में सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि सक्रिय है और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर टेलीस्कोप प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्स-रे स्पेक्ट्रोमीटर जो कि सोलर लो वर्णक्रम मापी है। लो एनर्जी की सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। सॉफ्ट एक्स-रे वर्णक्रम मापी है इसमें जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। L1 ऑर्बिटिंग एक्स-रे स्पेक्ट्रोमीटर है जो कि हार्ड एक्स-रे वर्णक्रम मापी है। हाई एनर्जी L1 ऑर्बिटिंग एक्स-रे स्पेक्ट्रोमीटर है जो कि हार्ड एक्स-रे वर्णक्रम मापी है। यथास्थिति विकल्पना सोलर फ्लेयर के विंड पार्टिकल एक्सपेरिमेंट इसका उद्देश्य है भार में सोलर विंड पार्टिकल एक्सपेरिमेंट भारी आयंस का उद्देश्य है और सोलर पवन में भारी आयंस प्रोटॉन प्लाज्मा एनालाइजर पैकेज फॉर आदित्य का विश्लेषण करना। यह भी सौर पवन प्लाज्मा एनालाइजर पैकेज फॉर आदित्य उपस्थित कणों में यह भी सौर भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के रेजोल्यूशन डिजिटल मैग्नेटोमीटर गया है। इसे त्रिअक्षीय चुंबकीय क्षेत्र समुच्चय लगे हुए हैं मापन करने के लिए बनाया गया है, और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal. Vehicle
यान पूरी तरह
performance
सामान्य,
normal.
सभी तंत्र सामान्य रूप से कार्य कर रहे हैं। यान पूरी तरह सामान्य कक्षा की ओर बढ़ रहा है। सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य-L1 के नेतभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। आदित्य-L1 के नेतभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। लैंड क्रोनोग्राफ सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप बेंगलुरु द्वारा तैयार किया गया है। सेंटर फॉर एस्ट्रोनॉमी एंड अल्ट्रावायलेट इमेजिंग द्वारा निर्मित है। इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। दोनों ही URO सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX दोनों ही URO सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित तिरुवनंतपुरम द्वारा निर्मित और PAPA में मैग्नेटोमीटर लैबोरेटरी फॉर इलेक्ट्रो ऑप्टिक सिस्टम्स बेंगलुरु द्वारा निर्मित में मैग्नेटोमीटर लैबोरेटरी फॉर इलेक्ट्रो ऑप्टिक सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी जारी रहने वाला है, जहां वरिष्ठ वैज्ञानिक अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी और फिर चर्चा के बाद वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे।
As we are in the no visibility region of the flight path, we take you to the discussion room. As we are in the no visibility region of the flight path, we take you to the discussion room more on the payloads and details. Connected with the Aditya-L1 room will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India's made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. After India's made history with the Chandrayaan-3 breakthroughs back to back, it has now set its eyes on our country's hat. In fact, these celestial bodies are very important and are considered as, in fact, these celestial bodies are very important and are considered as, the sun is the central body of our solar system. In multiple global the world revolves around it. The sun is the central body of our solar system for all planets. The world revolves around it. And it is a source of by all the scientists for all planets including the Earth behind the scenes. Today I am joined by all the scientists who have played behind the scenes to you from the Satish Space Center, and I am Sriharikota to you from the Satish Space Center. Today we will be discussing about the impact and the benefits of the Aditya-L1 discussing about the impact. So today we are joined by Dr. Anil Bharatwaj, Director of PRL. We are joined by Dr. Anil Bharatwaj, Director of PRL, Director of Indian Institute of Astrophysics, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics of Aditya-L1 mission, Dr. Sankara Subramanian, Dr. Durgesh Tripathi, Principal Scientist of Aditya-L1 mission, Dr. Durgesh Tripathi, Director of SCYDs, Nainital, Dr. Dipankar Banerjee, Dr. Satish, Director of PI of Papa, Nainital, and Dr. Vipin K. Yadav, Dr. Satish, PI of Papa, and Dr. Vipin K. Yadav, magnetometer, of joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 launch. Dr. Sankara Subramanian. To start with the principal scientist, why is Aditya-L1 mission so important? Dr. Sankara Subramanian. And what are the objectives of this mission? Why is Aditya-L1 mission so important, and what are the objectives of this mission?
ISRO as well as the Government of India, first of all, let me for providing a great opportunity for the solar and heliophysics community of the country. For providing a great opportunity for the solar and both solar heliophysics as well as astronomy thrives on data. Both solar, more the data you have, we get more understanding about the system. More the sun is our own understanding star, our dearmost star. So understanding sun is our own more important for our everyday life. Star, our dearmost star. So this mission Aditya is much more important for our everyday life. So this mission Aditya, which support was conceived initially, Professor U.R. Rao, along with support from Kumar and Professor G. Srinivasan. Professor U.R. Rao, we made sure that we will have a unique data set which is not available from any other mission. We made sure that we will have a unique data set. So the 7 payloads what was conceived for this particular mission internationally will provide the unique set of data what was conceived for this particular mission any other mission will provide a unique set of data, new insight into the solar and heliophysics community in India. New insight into some important solar and heliophysics community initiation of the coronal mass provides some important aspects like the initiation of the coronal mass some wave bands which are very important for the Earth ionospheric and some wave bands which are very important for the Earth and the high energy particles which is high energy radiations as well as the high energy particles, the solar flares and radiations as well as so these are the informations which would be available solar flares and coronal mass ejections. Which will so these are the informations which would be understand the sun, its dynamics, which will allow us to which is an important element for its dynamics as well as the space weather aspect, which is an important element for the current day technology as well as the space weather.
So now we move on to Dr. Anil Bharadwaj. Thank you so much for your remarks. So the sun is a very important energy source of life. Anil Bharadwaj. Having understood that, so the sun is a very important when it's angry source of life. How does Aditya-L1 help us through the mission? It creates a trouble when it's angry.
Thank you and
how does Aditya-L1 helps us through the mission?
First of all, let me tell you that Aditya-L1 is a multi-wavelength. First of all, let me tell you that Aditya-L1 is a multi-wavelength because it works in X-rays and multi-directional UV and visible. Multi-wavelength instrument because there are 7 experiments on board UV and multi-directional because it looks not only because there are 7 experiments on board also around and multi-directional because when the sun becomes angry in the sun direction but also there are two types of process which happens. One when the sun becomes angry, electromagnetic radiation. There are two types of process which happens. One is solar flares. That means, but along with that, there is the Earth mass which is also ejected out in form of plasma. But along with that, and that can take about 2 to 4 days also ejected out in form of plasma. What we are looking for that can take about 2 to 4 days is to see what we are looking for from the Aditya-L1 solar flares is as well as coronal mass ejections as the impact of solar flares. We have instruments as well as look at not only in the sun direction as they comes to the but also in we have other instruments which look at not only in the sun direction but also in other directions. The impact is that we need to see when the sun becomes quite angry. The impact what are the ways in which it is affecting the planet when the sun becomes quite angry. At one point being what are the ways in which it is affecting the planet Earth away from the Earth. At one point it is able to provide us a lot of new informations of the plasma and the it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations.
So now we move on to Dr. Annapurni Subramaniam. Thank you so much. So the science behind this mission is very unique. So what's the impact of this on the Earth behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
To put the thing in context, I'm the director of the Indian Institute of Astrophysics, and to put the thing in context, one of the major payloads of astrophysics, and we have delivered emission line one of the major payloads. So if you actually look at the words used in it, line because it is using. So if you actually look at the words used in it, it is visible. Emission line. So what is it detecting? It is the emission line of certain elements. Emission line. The corona. So what is it detecting? It is the emission which you get is in the terms of elements. It's not absorbing the light which is coming from the emission which you get is in the terms of. But it's already hot, so it's not absorbing the light which is coming from the so we are tracking but it's already hot, so it is coming down by emitting lines. Now what is the coronagraph? We are tracking this instrument makes using what? A total solar eclipse. Now what is the coronagraph? This instrument. So you are looking at the sun. A total solar eclipse 24/7 using this mission. So you are looking at the sun. Looks at the sun all the time as though it is always using this mission. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because you want to have the eclipse all the time. When sun is angry, because you want to see the corona. The corona is what? Why corona? Because when sun burps. Now, what is unique about this instrument? The corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona. What is so challenging about it? As close as possible. It is because the sun's corona is so challenging about it. Fainter than the sun's corona is a million times. So you have to not see the disk of the sun, but see only the corona. So this instrument you have to not see the disk of the sun, but see only the corona. But it is made, so this now it's going to the orbit. What we plan to study using this instrument is, but it is the corona, going to dynamics. What through this emission line you can actually measure the velocity, the corona, its dynamics. Through this emission line you can actually measure the velocity, you can measure how much matter is moving, and eventually how that matter will come. You can measure the velocity, you can measure how much matter is moving. So it's eventually how this instrument, along with the others, of course, the other PI will also be explaining about it. So it's overall this instrument, along with the others, will give you a lot of the other PI regarding explaining about it. So these holistically will give you a lot of information regarding not only the sun but also.
And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. And now are the PI of the paysuit Durgesh Tripathi, Dr. the payload suit. How is that different from other telescopes like Hubble or James Webb suit? And what is that different from other telescopes like Hubble or James Webb?
My voice is going to mumble
and what are you going to investigate?
Because I'm still in the awe of the launch, and my voice is going to mumble by. So because I'm still in the awe of the launch, and JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe. Whereas when we talk about Aditya-L1, it is going to look at one particular object. Whereas when we talk about Aditya-L1, it is going to kept on the other side of the sun Earth line at the L1 point, whereas it's also kept on the other side of the sun Earth line at the L1 point, whereas the James Webb Telescope. Now the scientific difference, of course, they also observe in ultraviolet, but now the scientific difference, of course, they also observe in ultraviolet, but alluded to Aditya is a multi-wavelength and also Professor Annapurna satellite, and they will be observing all across the electromagnetic spectrum satellite, and they will be observing all across the suit is going to be looking at the ultraviolet radiation. In particular, suit is going to be looking at the ultraviolet radiation emits from the lower and the middle atmosphere of the sun. And what we want to look at that how emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere how actually this radiation is coming and getting absorbed in the how actually this radiation is coming, what kind of effect it can getting absorbed in the chemistry of Earth's oxygen, for example, and what kind of also these explosions which are happening, how much radiation they are creating, for example, and how much effect also these explosions which are happening, how much radiation they are creating, and how much effect it might have.
Now we move on to Dr. Satish Thampi. Thank you very much, sir. You are connected with the payload Papa. Already the plasma particles on the moon are analyzed. With the payload Papa. How do you analyze already the plasma particles on the moon are and what is the importance of solar winds and how does it impact the sun? And what is the importance of solar winds and how does it impact?
Coming to this show. As my colleagues they mentioned actually about the sun. Today we have as my colleagues they mentioned our own star, that is the sun. Today we have, just I want to tell to the viewers that actually we are going to our own star, which is our hero, basically. Just I want to tell to the viewers that if you look into the mass of the solar system, which is our hero, basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system. Now when we are talking about the heliosphere, and also this sun is engulfed in that thing. Now when we are talking about, we have been studying in decades, maybe in centuries, all our planets are engulfed in that. But what we are lacking, we have been studying in decades, maybe in centuries. Its energy mainly in three forms. But what we are lacking actually is first one is the radiation, because my colleagues sun is giving its energy mainly in three forms remotely from our ground. The first one is the radiation, actually my colleagues already talked. Basically we are talking about the solar wind, but remotely from our ground. Space plasma as well as the magnetic. The plasma, this can be only studied by institute, what we call the space. If we study all these radiation particles, this can be only studied by institute, comprehensive understanding of the. If we study all these radiation, we are getting the first, we will get a full comprehensive understanding from the Indian soil, and we are making we are getting the first. And of course I am thankful to ISRO and all my colleagues and we are making this opportunity and all my, and of course I am thankful to ISRO. This is the opportunity we got actually. We are mates from SDSC and all my scientific all the three things. This is the opportunity we got actually. Already they mentioned about the radiation actually all the three things, radiation particles. And just I want to emphasize they mentioned about the radiation. That's why we named it as Papa. Papa means plasma and just I want to emphasize on the particles. This is developed. That's why we named it as Papa. Papa means plasma and laser package for Aditya. And now this instrument has two components. If you look at the solar, basically it comprises of 95%. Now this instrument has two components. If you look at the solar, then equal number of electrons, 95% is protons. So our Papa is a comprehensive package measuring both ions and the electrons. Then equal number of electrons also. Now this Papa is a comprehensive package measuring both ions and the major transition events like corona. Now these electrons, like huge mass which is coming out of the sun, basically the major transition events. Basically when we are talking about solar and huge mass which is coming out of the sun, basically it's a plasma. Basically now we are talking about solar and actually they only actually modulate the energy and momentum of the planetary atmosphere. Now these particles actually they only actually quiet like the energy and momentum of the planet. What we are getting the ambient solar. See, when if you look into that thing, actually, that one actually gives what we are getting the ambient solar. What we call the so if you look into that thing, actually, that one actually what we call that normal routine. What we call about the the interaction sun is what we call that normal routine. It gives like in a CME, CA or this sort of events. When there is sun is angry, really going to affect. It gives like in a CME, CA or this sort of events are happening. Now our intention is to understand first of all actually what that what we call basically the solar wind. Now our intention is to understand first of all actually what how the solar wind behaves, and also how ambient condition mass ejections which is passing through different how the solar wind how actually what are the and also how this what we call mass ejections which is passing through different planets, how actually what are the different that you want to what we call about that. So one thing is actually physics subject to understand because we are getting an ideal that we want to understand, which is so one thing is actually physics subject to and we will be seeing the events exactly there. Second thing is actually we can definitely monitor the parameters. We will be seeing the events Papa will measure the electrons. Second thing is actually we can definitely monitor the direction. What is the Papa will measure the electrons and mass information. We will be getting energy. So if we know these things direction related to electrons as angular electrons, we don't want mass information. But for the ions, so if we know these things related to coupling all this information, we don't want what we can do is we can derive the plasma mass information. That will be definitely going into the modeling part. What we can do is we can derive the plasma moments. That will be definitely going into the modeling part actually. So in due course actually, the yellow in addition to other effect of this space, we will be able to touch. So in due course actually, the yellow that actually as we mentioned actually earlier with the lunar mission we achieved, we try to understand that thing. That actually as we mentioned actually earlier with the lunar mission we achieved, now all try to understand that thing. Really it changed this plasma studies, changed the perspective of the moon.
Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. Thank you so much for that, sir. And now we move on to Dr. You manage the beautiful solar observatory at Nainital. So how do you think the studies you manage the beautiful solar observatory at Aditya-L1? How do you think the studies about the history of solar observatories will supplement Aditya-L1?
That's right.
Can you tell us
India
something about the history of solar
looking
observatories
at the sun
in India?
from the ground. That's right. In fact, from Kodaikanal Observatory, we have been looking at the sun for more than 100 years. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. In the lakeside, and also we have beautiful, we are looking at the solar observatory. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. This is a fantastic opportunity. So this was very originally more than 10 years back. We were only looking at this is a fantastic opportunity. And originally more than 10 years back, we were only this idea. Why are you be taking baby steps? Professor U.R. Rao suddenly came up with this idea. We should go. Why are you much taking longer distance? And then this opportunity came in. We should go to Lagrangian-1 mission, longer distance. And then all this opportunity came in. Got the Lagrangian-1 mission. There are multiple countries, all the scientific institutions proposed. So eventually now we have a Lagrangian-1 observatory proposed. So eventually now we have a Lagrangian multi-wavelength observatory. So that's very important. And as you heard from my colleagues, shorter waves multi-wavelength space. And in addition, the ground-based observations are also incorporated from the space. So a combination of the ground-based observations and the space platform. So a combination of the ground-based. And since you asked about the question about the how Aditya in the overall heliophysics. And since you asked about the question about the how Aditya in the overall we only have three spacecraft around Lagrangian scenario. We only have three spacecraft around Lagrangian 1 point. Fantastic achievement primarily from India. If you could reach L1. So I think again this is with the full observatory class mission from India. If you could reach L1 altogether with the full. I think this is a great opportunity, and we are all looking forward. So and as I mentioned, probably we'll request that we are all a better ground-based facility. And as I mentioned, probably we'll request that a better ground-based facility. We have already projected a national very nice ground-based from the ground.
And now we move on to Dr. Vipin. What is the contribution of magnetometer to Aditya? So you're in charge of the magnetometer. What is the contribution of magnetometer measurements are very crucial in space. You see, especially at field measurements are what we are going to measure with magnetometer is, and especially at interplanetary magnetic field. What we are going to measure with magnetometer is the interplanetary magnetic field. Typically, these values at L1 point are around 5 to 10 nanotesla. So typically, these values at L1 point are around
5 to 10 solar event, such as the coronal mass ejection, increases or whenever there is solar magnetic solar event. Now, such as the coronal mass ejection events are crucial to monitor the near Earth space weather. Events are crucial can have to monitor the near Earth space weather. If you remember, these can have there was an event when the power lines were snapped few years ago. If you remember, that was because of there was an event when the power lines were snapped few years ago. So to keep an eye that was on the surroundings of Earth event, we need these measurements. And apart from that, surrounding solar wind observations also, we need these measurements. And apart from that, for solar wind observations also.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya-L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are two unique instruments built by URAO Satellite Center that is going to cover the solar flares from 1 kV to extremely high energy, about 200 kV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these two instruments, along with the other two instruments, VLC and SUIT, we are going to address this $1 million questions as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya-L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya-L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPEX payload, which stands for Aditya Solar Wind Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-direction information which is available from the ASPEX payload, because it consists of two sensors, SWIS and STEP, essentially giving you in two different energy bands. And therefore, we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankara Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrosat and Aditya-L1?
Yeah. So now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya-L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards Sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, the next generation will come and utilize this data, because the data is for the community. So unless, we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan-3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan-3 mission, that is the Aditya-L1 mission and Chandrayaan-3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you. Thank you very much.
Thank you everybody for participating in this discussion. And now we move on to the control room.
Thank you, Srinidhi. And I thank all the panelists for enlightening us about the high-tech science that Aditya-L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं, यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV-C57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और फिर
टर्मिनल एक्वायर्स टेलीमेट्री सिग्नल।
जी हाँ, इसकी पुष्टि हो गई है शिप बॉर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV-C57 Aditya-L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, SHAR, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Fourth stage engine started for band 2.
यहाँ अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य-L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं, हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Stage performance normal.
Intended trajectory closely matching the prediction. Presently, the shipborne terminal is acquiring the signal. Few seconds later, there will be another no visibility phase before Koru starts to acquire signal.
जी अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार की भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन गुरु स्थित फ्रेंच गयाना स्थित गुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya-L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya-L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads, and the orbital parameters, burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya-L1.
इस दौरान आइए आपको अवगत करा दें आदित्य-L1 के मुख्य उद्देश्य से। आदित्य-L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 भार लगे हुए हैं जिनकी मदद से आदित्य-L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं इसके गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए आंकड़े प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की अब चतुर्थ चरण को बंद कर दिया गया है, अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है
injection conditions are achieved.
और इसकी भी पुष्टि हो चुकी है कि आदित्य-L1 के अंतक्षेपण की स्थितियां प्राप्त की जा चुकी हैं.
We are now eagerly awaiting the injection of the satellite as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी.
Highly anticipated event next is the separation event of Aditya-L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर. कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है. यान से अंतरिक्ष यान आदित्य-L1 का सफलतापूर्ण अंतक्षेपण अभी बाकी है.
For Aditya-L1, ISRO has developed advanced flight dynamics software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मन
Aditya-L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है. इसकी पुष्टि कर दी गई है.
Aditya-L1 mission accomplished. Handing over to mission director.
And we have a confirmation of Aditya-L1 separation. The mission has been accomplished.
PSLV-C57 has injected Aditya-L1 satellite into the desired intermediate orbit. PSLV-C57 Aditya-L1 mission is accomplished.
आदित्य-L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है. इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए.
Do join us for the address by Chairman ISRO Secretary Department of Space Shri S. Somnath.
सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए. अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए.
Congratulations. The Aditya-L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission. of Aditya-L1 to put it in the right orbit. Now, from now, the Aditya-L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shaji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh, so I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya-L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
Thank you. May I request the project director of Aditya-L1, Nigar Shaji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya-L1, and I'm extremely happy that Aditya-L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya-L1 solar panels are deployed and the spacecraft will be normal. And Aditya-L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans-L1 injection, and finally insertion into the halo orbit in the Sun-Earth Lagrange point L1. Once this Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the center directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbiting session and further great science output from the Aditya-L1 mission. Thank you all.
Sri Biju, the mission director and the project director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya-L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya-L1 mission, just following the Chandrayaan-3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you. Contribution from across the center, this could be done. So let me start with the Director VSSC.
Good afternoon, India.
So this is the 59th mission of PSLV, and 1993 was the first mission. So this is the 30th year of PSLV. So it's PSLV is on the threshold of Shashti Purti. With the next launch, it will be crossing, making 60th launch. I wish all the very best to the satellite team, all payload specialists for the operation of the payloads and satellite in coming days. And I'm take this opportunity
to the launch event of India's prestigious LVM-3 M4 Chandrayaan-3, the mission of ISRO to the moon. I am Madhuri giving the commentary in English. With me is my co-commentator Shri Vikas Swarnkar giving the commentary in Hindi. We are joining you from the Mission Control Center at Satish Dhawan Space Center, SHAR, Sriharikota, the spaceport of India. The launch of LVM-3 M4 Chandrayaan-3 is scheduled to take place today, the 14th of July 2023 at 14:35 hours Indian Standard Time from the second launch pad. The mission intends to place Chandrayaan-3 weighing 3,900 kilograms into an elliptical parking orbit having a perigee of 170 kilometers, an apogee of 36,500 kilometers and an inclination of 21.3 degrees. Eventually, the destination of Chandrayaan-3 is the moon, located 384,000 kilometers away, which will be achieved through a series of orbit raising and course correction maneuvers over the next few weeks.
नमस्कार। भारतीय अंतरिक्ष अभियान और इसरो के गौरवपूर्ण इतिहास में एक और अध्याय जुड़ने जा रहा है, जिसके साक्षी हम सब होंगे। आज 14 जुलाई 2023 को इसरो के सतीश धवन अंतरिक्ष केंद्र के श्रीहरिकोटा के द्वितीय प्रमोचन मंच से भारतीय मानक समय के अनुसार दोपहर 2:35 पर LVM-3 M4 चंद्रयान-3 मिशन का प्रमोचन किया जाएगा।
ब्रो, लद्दाख चले? लद्दाख चलेंगे ना ब्रो। ब्रो, गोवा चले? चलते हैं ना। ब्रो, गुलमर्ग? हाँ, चलते हैं ना। ब्रो, जाएंगे ना। अब कब?
इनके सपनों के हॉलिडेज के प्लान्स तो टेक ऑफ ही नहीं हो पाए, पर ऐसा आपके साथ ना हो, इसीलिए सही समय पे SIP करो। म्यूचुअल फंड निवेश बाजार जोखिमों के अधीन है। योजना से